Okay, so this is the last section for chapter 9, 9.8-2. We're going to make sure that we have the an outline of what it means to have factored a polynomial completely. When you have factored a polynomial completely, you will meet these guidelines. It will be the product of unfactorable polynomials with integer coefficients. Can we review the word integer? What does that mean if you have integer coefficients? Madeline? Negative and positive numbers and 0. And what will it not include? Unreal numbers. Fractional pieces. No decimal, fractional pieces. It's got to have integer coefficients. So that would be the whole numbers and their opposites, like on our number line. Okay, so if you've got fractions, you've got to blow it up. Okay? So we learned that the first thing we do is factor the GCF, or the GCM. We factor the largest shared factors out, common factors out of the entire expression. Once we've done that, we look for patterns. We look for the difference of two squares. The difference of two squares will give us what pattern? Say it loud. Sum and difference pattern. Okay, so you start with like a binomial, two terms, and you end up with two binomials, sum and difference pattern. The perfect square trinomial starts with three terms and ends in what pattern? Remember? It looks smaller because it's the, say it louder? Square of a binomial, okay? So if you have a pattern, we use what we know. We go from perfect square trinomials to squares of binomials. We go from the difference of two squares to sum and difference patterns. So those are the first thing we look for. If you don't see a pattern, then we factor the trinomial into binomial factors. We take a look at the signs. If A is negative, what do we do about that? Factor out a -1 out of the entire trinomial and change all the signs. And then we decide if that C is negative, we'll subtract, right? Adding and subtracting. If the C is positive, we'll have either two positives or two negatives in our binomials. We use all of those strategies that we've practiced, right? And then we factored 4-term polynomials by grouping. And in yesterday's assignment, you took a 3-term polynomial and you made it a 4-term polynomial so that you could group it. And I think we'll add one here just for those lost souls who aren't at school. Okay, so because we hadn't done taking a trinomial and creating a 4-term polynomial out of it, we're going to add another sample here. So what we learned, what you were supposed to learn in the assignment was, the first thing you do when you see this and you're like, this is hard to factor, what could I do? Okay.
Multiply 21 times 4.
Multiply your A times your C. A is 21, right? And C is -4. What is 21 times -4? -84. Good. Okay, so we've got -84. So it's a negative. And we need to know the factors of -84 that could become 8 when you add or subtract. It's a -84, so it must be we subtract the factors and we get 8. Okay? So let's see, what goes into 84? 4 times what? We just did it.
21.
Now, do those subtract to give us 8, the middle term? No. So what are the factors of 21?
7 and 3.
7 and 3. Oh, okay. So when I look at 7 and 3, do I see any way I could recombine these factors to give us a difference of 8? Let's factor this too. So here are all the factors. There it is. Okay, so 14 times 6 is one way to look at 84, and look at the difference of 14 and 6 is 8. Okay, so we're going to rewrite this polynomial as, which one of the factors would be positive? This is positive, right? So 14w and then minus 6w. So these two terms equal 8w, which keeps this new polynomial equivalent to the original. Yay. Okay, so now we're going to use the grouping we learned yesterday, right? So what is the GCF here in the first 7? 7 and w, right? 7w times 3w plus 2. Good. And now we want 3w plus 2 out of the second, and I see all these negatives, so what will I pull out?
Negative.
Good. Negative 2 times 3w plus 2. Okay, so we have this common 3w plus 2. So that is one binomial. And the other binomial is combining these two, right? So we've got 7w minus 2. There it is. Not an easy factorization, but it is a handy way to attack a problem that has giant numbers in A and in C. Okay, and if you want to see more, this was all explained on page 611. Okay, so let's go ahead and practice factoring completely. Start with this, factor it completely. Okay, so what are you pulling out of this? Is there a GCF right now? Jenna?
3x.
3x. And what are you left with?
We're left with x squared minus 2.
Okay, so are we done? Before you're done, you look at this and say, is this something I could factor further? Is it? It's the difference of two perfect squares, so you better not stop, right? We still have 3x, but when we have the difference of two perfect squares, what pattern do we get? Good. So, Jenny, you want to tell us?
It would be x minus 2 plus 2x minus 2.
You know, the only reason I'm writing it that way is because it's called the sum and difference, so I don't want to confuse people. But you may write it either way, as long as you have both signs. Okay? Okay, here you go. Pause and come back. What's the GCF here? Do you see? Kyle? What can you pull out of each of these?
2y.
Good. So if I pull 2y out, what do I have left? If I put third, it would be too much, wouldn't it? Second. Good.
And then minus 6y plus 9.
Just plain old 9. Good. Okay. Is this trinomial factorable? And what kind of a trinomial actually do we have? Look at the first and last. Perfect square trinomial. Right. So when you have a perfect square trinomial, you're going from the 3-term expression down to a 2-term, right? So we're going to have the square of a binomial, we hope, if the outside inside is negative 6y, right? And so, Kyle, what's the square root of y squared? What's the square root of 9? And what would the sign be in the middle? And so tell me, when you multiply y times negative 3, what do you get? And negative 3y twice, does that equal negative 6y? Yes, so good. Got it. And there it is, completely factored. If this was set equal to 0, what would the solutions of this equation be? If it was, the solution out here would be what? Just 0, right? It's 0. And the solution here would be? 3. Good. What is the GCF? Good, so we pull m, and what's left? Okay, and we look at this trinomial. Is this trinomial a perfect square trinomial? No, 8 is not a perfect square. Plus, look at this, it's negative, right? So it's definitely not. Is this factorable, though? You think so? Are there factors of -8 that could become -2? 6 times 2 are not factors of 8.
4 and 2.
Okay, Sabrina, so what would be in the first terms here? M. And then the last term is -8. So what does that mean for the signs? Negative and a positive. Good. And Sabrina, what factors of 8 subtract to be 2? 6 times what is 8? 6 times, not something we want to deal with. It's a fraction. So, no. 8. Give me the other factors of 8. 8 times 1, and then what else? 4 times 2. Do 4 and 2 subtract to be 2? Okay, good. So which one's going to be positive? Which one's negative? Good. 4 is negative and 2 is positive. So if you FOIL this, you have positive 2m's, negative 4m's, negative 2m's. Okay? And negative 8. So there's no question. You can check your answers. You should know that they're correct because you FOIL it. No question. Okay, so the only difference now is that we have an equation, so we can state the solutions. So, Ellie, what is the GCF here?
W.
Okay, and what's left?
W squared minus 8W plus 16.
And it equals 0. So this was already set equal to 0. So is this what remains? This is a trinomial. Is it a perfect square trinomial?
No.
Is this a perfect square?
Yes.
Is this a perfect square? So it may be that it is. So if it is, it will give us what pattern?
Sum of difference.
No? Not sum and difference? Square of a binomial. We go from wide to narrow. Wide to narrow. Right? So, Ellie, what is the square root of w squared?
W.
And the square root of 16?
4.
And the sign in the middle
19.
will be negative. So let's try. W times -4 is? And 2. Negative 4w twice. Is that -8w? So we got it. Good. So now tell me, what are the solutions that would allow this equation to equal 0? W is? Very good. 0 and 4. Excellent. Good job. Try this. Come back and look at the answer. Okay. So there we have it. 3 solutions. Notice that we have a cubed equation, a third-degree equation, and we get 3 solutions. When we graph that, this means that we're touching the x-axis in 3 different places. Okay? For those, I know you haven't graphed yet, but this would be some sort of a cubic equation, 1, 2, 3. It would touch down 3 places on the x-axis. Okay? Pause and come back and check your answer. Okay, so we pulled out the C and saw not a perfect square trinomial. However, it was factorable. And so there you go. Okay? Now, one really, my favorite all-time polynomial equation, what is the value of x? This is a great word problem. Okay, it's multi-step because there's a lot you have to do to find x. So the first thing we notice is that we've got how many dimensions here? 3 dimensions. Volume is 3-dimensional, right? So if we start with the formula for the volume of this, this is the most basic. I mean, I could make this harder. I could give you a cone or something, you know? But this is simply a rectangular prism. So how do you find the volume of a rectangular prism? So we would say base times height times the height of the prism. Base area times height, right? Or in like secular terms, they would say length times width times height, right? In everyday kind of language. So we do have this information. Do you see it? We have volume. What is the volume? It's given. So fill it in. We have whichever side you want to name length. It doesn't matter, does it? So Cassandra, what's the length?
X minus 1.
Okay, volume is length times width times height. So just plug it in, distribute, multiply, get 4 terms, subtract your 72. And